Alright, so now we're going to be combining everything we've been talking about with piecewise functions into this lovely word problem. Okay, which there will be two parts to the word problem. If you're not in honors, we're only going to focus on this top part. If you are in honors, I do expect you to do this bottom part. So the top part will just be solving a problem that involves piecewise functions concepts, and below the fun part, we'll be putting it all together. We'll be writing a piecewise function to represent the word problem, and we'll be solving using the piecewise functions, and we will be graphing our piecewise functions. So let's get going. I'm super pumped up. Alright, so our word problem is Shelly earns $8 an hour. She earns $12 an hour for each hour over 40 that she works. Figure out how much Shelly earns after working 50 hours. So, the first thing I do when I solve math problems is to underline the important information in the word problem, which usually in math word problems, the important pieces are usually something with numbers. So, Shelly earns $8 an hour. That will probably come in handy in the problem. She earns $12 an hour for each hour over 40. Okay, so all of that's important. And in the very end, we're going to figure out how much Shelly earns after working 50 hours. So those are the important parts of our problem. So what we're going to do first, we're going to kind of break this down into two different pieces. We're going to see how much Shelly makes when she earns $8 an hour versus when she works $12 an hour. Okay, which it all surrounds this over 40 component. So Shelly earns $12 an hour for each hour over 40. So that means if Shelly works up to 40 hours, including 40 hours, she's making $8 per hour. So when Shelly works from 0 to 40 hours, so we can include 40 because anything over 40, so past 40, is when she starts making $12 an hour. Alright, but from 0 to 40, she makes $8 per hour. So to figure out how much she earns for that total amount, if she works from 0 to 40 hours, that's a total of 40 hours. 40 minus 0 is 40. And to figure out how much she makes over 40 hours, she makes $8 per hour. So if we multiply 8 times 40, we will figure out how much she earns over 40 hours. So 40 times 8, if you think about it, 4 times 8 is 32, so 40 times 8 is 320. And we must include our units when we solve word problems. Your answer is naked and disgusting if you don't include units with your word problems. So it'll be $320. Alright, so that's how much Shelly earns after working $40 or 40 hours. So now, we want to know how much she earns total after working 50 hours. So, when we go past 40, that's when Shelly starts earning $12 an hour. So from $40 per hour, let's see, I'll do in yellow. So when she goes past 40, all the way to 50, that is when Shelly starts earning $12 an hour. So to figure out the total amount of hours from 40 to 50, 50 minus 40, if you subtract the two, will give you 10. And during that period, since we're now over 40, she makes $12 an hour. Now, the reason why we didn't say 0 to 50 is because the first 40 hours we already accounted for up here. She makes $8 per hour for those first 40 hours. So we don't say 0 to 50, we start where we left off here and continue on. So 10 times 12 will be $120. But the problem's asking how much she earns in total after working $50. So let's figure out the total earnings after 50. So if we simply just add these two together, that will account for how much she has earned over the total 50 hours. So $320 plus $120 will give us a total of $440. Holy hot dog, that's a lot of money. I wish that I made that much money right now. Alright, so Shelly has earned $440. That would be our final answer after 50 hours. Alright, awesome. So now we will be stepping up the problem a notch. Okay, we'll still be solving for how much Shelly earns after $50, which we just did, but we are going to be making a piecewise function about the problem, and we're going to be graphing the piecewise function, which should help us get the same answer. So, if you are not in honors, if you want to pause the video now, that's fine. You will not be tested on the material down here. But if you are in honors, you do need to continue on with the video. Okay, so let's continue on. So we already know this first part. Shelly earns $8 per hour. She earns $12 an hour for each hour over 40. What we'll be doing is writing a piecewise function to represent this scenario. Holy hot dog, I'm pumped up. After that, we're going to sketch the graph of Shelly's earnings versus the number of hours she works up to 60 hours. And then we're going to figure out how much she earns after working 50 hours, which technically we already did. We already know that. So we're going to keep that number in the back of our mind. And if we did the problem correctly, we should end up with the same answer as up here. So let's get going. Now, something we'll have to keep in mind. Later on in the problem, not yet, we'll be using point slope, which the equation of point slope is y minus y1 equals m times x minus x1, which m is the slope, which in this case, the slope is going to be, slope is always a rate of change. So how much a y value is changing over an x value changing. So if we look at our graph, the y values are going to be how much Shelly has earned, and the x values is how many hours she has worked. So when we write our equation, our slope is going to be the dollars per hour, or how much she makes per hour. That's kind of what our slope is going to be focusing on. Okay, and the x1 and the y1 is just going to be a point we're going to be using in the problem that involves something, how much Shelly has made over a certain amount of hours she has worked. Okay, now the y and the x, not the y1, x1, but the y and the x, we're just going to leave alone. Okay, but we're going to come back to that later. Alright, so eventually we're going to be graphing this. So if you want to go ahead and copy down the graph, you can. Okay, and I already know how high it's going to go, so that's why I made it up to 700. So on the y-axis, we're going to be recording how much Shelly has earned. So those are the y values. And on the x-axis will be how many hours Shelly has worked, and that will be the earnings per hour. It's always good to label your title and your axes. Alright, so we know we're going to have two piecewise functions because there's two scenarios going on. One scenario, Shelly earns $8 per hour, and one scenario, she earns $12 per hour. So those are going to be our two functions we're focusing on. Now, once we come up with our functions, like before the graph, we're going to fill out our chart and just graph. So that part won't be too bad. The hardest part with these problems is actually coming up with your piecewise function. Alright, so let's continue on. So, the first scenario we're going to talk about is the $8 per hour. Okay, which that surrounds the $40 mark, which in this case will be under 40. So when we write our piecewise function, the first thing I like to do with word problems is write the bounds or inequality, not the function. So she makes $8 per hour up to 40, and 40 can be included. Okay, so the hours those are going to be our x values, so that's what I'm going to be using for inequality. So the smallest amount of hours that Shelly can work, since this is a real life scenario, she can't really work negative hours. That would kind of be working in the past, which is impossible, unfortunately. Unless Shelly's just really skilled, but I don't think she's that skilled. So we're going to start this at 0. And Shelly doesn't really earn money at the 0 hours mark. So we can't really equal zero hours. Now, I'm not going to nitpick too much, but technically, we can't equal 0 because you don't really make money if you haven't worked. Unfortunately, our society does not work that way. And since this is going up to 40, all the numbers will be greater than 0. That's why I chose the greater than. These are x's, so I'm going to include my x's. Now she makes $8 per hour up to 40 hours. Okay, so she can equal to 40, and these numbers are in between 0 and 40. So these numbers are less than 40 and can equal 40. So my first interval is from 0 to 40. Okay, so now we're going to come up with our function. So like we said up here, our slope, these are going to be linear functions because she gets paid a constant amount. She's not like works 1 hour, gets paid $8, works the next hour, gets paid 16 or something like that. Every hour she makes $8 per hour when we're working up to 40. So this is a linear function. So in this case, this first one's going to be a pretty simple equation. Just like up here, to figure out how much she made over the number of hours she works, we just multiplied the number of hours she works, which that's the part that changes, and no matter what, she made $8 per hour. So 8 is the part that never changes, so we're going to have an 8 there. The part that does change or varies will be our variable. The part that can change in our interval is the number of hours she works. So we're going to say the number of hours she works is an x. Alright, so that's our first equation. So, like we did before, we're going to fill in our x values, solve for y, get our wonderful points, and graph them. So, remember we have to pick the numbers in our interval first. So we're definitely going to use a 0 and a 40, our start point and our end point. And then we're going to pick a number in between, which, I don't know, a good number is 20, why not? Okay, so our equation is 8x. Alright guys, let's start solving. So our first one will be 8 times 0. We're going to fill in 0 for our x, which gives us a $0. Alright, so our point, when she works 0 hours, she makes $0, which makes sense. Alright, the next one, we're going to fill in $20. So 8 times 20 will give us $160. So after working 20 hours, she makes $160. Alright, and then our final point will be 8 times 40, which equals 320. So after working 40 hours, she makes $320. Alright, so let's get this graph. Now beforehand, we have to be careful. At the 0, since x cannot equal 0, remember that's going to be an open bubble. So I'm going to open bubble at 0, 0. Alright, the next one, remember anything that's not in the inequality is always closed. So since 20 was not one of the numbers in my inequality, it'll be a closed bubble. So my next point is at 20, 160, which you just kind of have to approximate on the graph. It's not going to be perfect. So 20 to 160, I'd say it's like right here, so. Alright, and then my last point is at 40 and 320, which when x is 40, it can equal it because we have the line underneath. Okay, so this will be a closed bubble. So we'll be at 40, 320. So that's roughly right here about. Again, you just approximate it. And since this is x to the first power, this should be a line. So if you did it right, it should be a line, but since these aren't perfect, since we had to approximate some, it might not be exactly perfect. So just do your best. So our first one goes to here. Alright, so that's where our first one stops. Okay, which if it helps you, if you want to draw in, you know, your little lines to show where it starts and stops. We start at 0, which I'm not going to draw the line there since we already have that. So it goes from 0 to 40. So this should stop at 40 on our x, which it did. So yay. Which I didn't quite make it since I was approximating, so I'll just go on further. Alright, so there's our first line. Okay, now the next one involves over 40, which it says that you need to sketch a graph for Shelly's earnings versus the number of hours she works up to 60 hours. Sorry, up to 60 hours. Okay, so let's make our inequality first. So this one will be in yellow. Alright, so this problem is going to involve when she starts making $12 per hour, and that will be focusing on the over 40. Okay, and they only want us to make our graph up to 60. So that will be important. And we want to know how much she earns after working 50 hours. So it might be a good idea to include 50 in our table, so we'll know eventually how much she'll make after working 50 hours, which I know you already know, but if we do it right, we should get the same answer. So let's start making our inequality first, and then we'll talk about how to make our equation, which that's when point slope is going to come in. Alright, so this one, We know we're over 40. Okay, so if we're over 40, first of all, we're larger than 40. And if we're over 40, we cannot equal 40. So our x value is going to be larger than 40, and it cannot equal it. So we're not going to do the equal to symbol. All right, and since the problem said we only had to make our graph up to 60 hours, that means we can also equal 60. And since these numbers are larger than 40, they'll be less than 60. So we're going to say less than or equal to 60. Okay, so if you want to draw your little tick mark so you know where it starts and stops, so that helps you. Now would probably be a better time than after. So let's go ahead and do that. It's going to stop at 60. Alright, so we know the next section of our graph, the yellow one's going to be somewhere in this middle section. Alright, now this is the tricky part. Okay, we can't just say our equation. Before we said the slope involves how many hours she works, which is 12 in this case, or I'm sorry, how much money she makes, and the x is the part that changed, which is the amount of hours she works. So we can't just make it 12x because something has already gone on. Okay, I can't just say, after, 50 hours, I can just multiply that by 12 and get her total. Okay, because now we're focusing on the total amount she has earned, not just up here when we calculated this on our own. So we have to start off where we left off in the problem to know the total, to get an accurate count of the total. Up here we kind of separated it and then found the total. But I want the graph to do this, so we don't have to do this step. So the way we do that, that's kind of how our piecewise, our point slope comes into play. So the slope that we're going to be focusing on up here, our equation is going to look like this, but our final equation is not going to look like this because things have already occurred. So the slope we're going to be focusing on is, remember, the rate of change, which in this case she makes $12 per hour. So our slope is going to be 12, which is our m in our point slope equation. Alright, and then we need a point. In point slope, you need a point and a slope. It's the name, point slope. So we know the slope, the rate of change, is the 12, and the point we're going to use is the point where we left off, or our start point. So the point that we left off, the last point in our previous problem, is 40 and 320. So we're going to continue on with our total at that point. So we're going to start at $320 and go up from that. So we're going to be using this point somehow. So the point you use in point slope will be where you left off, which will in this case be our start point because we're starting a new graph. So our point is going to be 40, 320. So to find our new equation, which will give us the total amount that Shelly earns, now that she's starting to make a different amount, we're going to be using this equation up here, which I'm going to copy it down here. Alright. So this is our m, and this is our x1 and our y1. And we leave the y and the x alone. Okay? So we're going to have y minus our y1, which is 320, equals our slope, which is m, which in this case our rate of change is the 12, times x minus our x1, which our x1 is the 40. Alright, now usually when you solve an equation, you're going to distribute out the 12 first. Okay, but we're not even going to do that. I'm not going to make you do that to make your lives a little easier. All we're going to do is get y by itself, which to do that, we need to bring the 320 to the other side. So the way that we can do that, okay, to bring negative 320 to the other side, you do the opposite. So we're just going to be adding 320 to the other side. So my final equation, which this will cancel out, turn to 0. My final equation that we'll be using is y equals, that canceled out, 12 times x minus 40 plus 320. Okay, the reason why I added on the end, we can't really add something into a parenthesis, especially if there's a number on the outside that will eventually multiply. So we're just going to write 320 on the end. So this is going to be the equation we use up here for our second piecewise function. This is what we use for when she made $12 an hour. Now the reason why it is, if you want to know, okay, the X represents the total amount of hours she worked. So like up here, you know, when I want to know how much she made after 50 hours, we got 10 because we did 50 minus 40. Well, if I put in 50 hours right here, we would do 50 minus 40 and get the 10. Okay, and then we do 12 times 10, like we did up here, to get 120. And then all we did to get our total was add 320 on it. So that's why there's a plus 320 on the end. So that's kind of the reasoning behind that. You don't have to quite understand it to solve, but that's kind of what that means. Okay, so that's our equation. 12 times x minus 40 plus 320. I'm out of space. Sorry, I had to squeeze that in. Plus 320. Sorry, guys. All right. So now, to get our final graph, we're just going to do the same thing before. This time we have a start and an end point, so we definitely include those in our table. So I'm going to include 40 and 60. 40 and 60. All right, and then I'm going to pick a number in between 40 and 60, which, since we want to know how much Shelly earns after 50 hours, it might be a good idea to include that in our table. So I'm going to include 50. Why not? Which again, if we did this right, we should get 440. So let's see. Okay, so our equation is 12 times x minus 40 plus 320. All right, guys, let's get going. So I'm going to substitute in these bad boys down here for my x and solve. So I have 12 times 40 minus the 40 plus 320. All right, now 40 minus 40 is 0. All right, and then plus 320. All right, so 12 times 0 is 0, and 0 plus 320 will give me 320. So my y value after Shelly has worked 40 hours, like we found up here, she makes 320. Holy hot dog. Alright, so we already know that. That's a given. Alright, now 50. Same thing. So we're going to put 50 in our parentheses. So 50 minus 40 plus 320. Alright, 50 minus 40 is 10. So we have 12 times 10 plus 320. So 12 times 10 is 120. And then 120 plus 320 is 440. So when Shelly works $50 per hour, or $50, she makes $440. So after 50 hours, Shelly makes 440, which, yay, we got the right answer. So technically, we already found the answer. It's right here in this point. Okay, after $50 or 50 hours, she makes $440. So if you want to box that, so we keep that in mind. So after 50 hours, she makes 440. That's technically the answer to our problem. Alright, and then it says to make our graph up to 60 hours, so we might as well substitute that bad boy in. So 12 times 60 minus 40 plus 320. Alright, 60 minus 40 is 20 plus 320. Alright, 12 times 20 is 240, plus 320 will give you 560. So after working 60 hours, Shelly has earned 560. Alright, so now the final thing we need to do is graph this bad boy right here. Okay, so remember, we gotta check our bounds. Okay, at the 40, since x cannot be 40, technically it's an open bubble. Okay, but this is the exact point as the point we already had graphed. And since that one is a closed bubble, remember, closed bubble always wins in the battle against open bubble. So even if I put an open bubble there, technically it's still closed. So that one's taken care of. Now my next point is at 50, 540. So 50 and then up to 540, which again, just approximate to your best. 540 is right here about. And remember, since that's a number that's not in my inequality, always close bubble. And my last bubble, since x can equal 60, will be a closed bubble. So my final bubble, it'll be at 60 and then 560. So 60 all the way up to 560. So about right here. 560, so yeah, right here. And you guys, technically, since this is linear, since this is x to the first, it should be a line, but since this isn't perfect, it might not quite be a line. So let's see, I might need to go up higher. Alright. And again, my graph is not perfect, so. Alright, so I guess it should kind of be up here more. Alright, sorry about that. Alright, so this is our lovely graph. So this maps out the total amount that Shelly makes per hour. So again, we're not breaking it up into pieces and then finding her total. This is her complete total. So that's the lovely graph. And again, the answer, after 50 hours of working hard, Shelly has earned $440. And we saw that based off of this point right here. Alright guys, it's been totally awesome working with you. I hope you had as much fun as I did.